Well, hello and welcome to this lecture where we are going to understand what was the need behind this object-oriented programming paradigm. So we call Java as an object-oriented programming language. So what does that actually mean? To understand that, we need to go back like 30 to 40 years and see how programming languages have evolved over the time. So initially, we used to write code in low-level programming languages which was used to provide one level abstraction on top of the machine understandable code, which is very difficult to understand and comprehend. Example of that would be assembly language. So as you can see here, this uh, particular example that you see here is that of an assembly language. So here at the first look, you won't be able to understand what this program is doing. Well, let me tell you, this program is for a Fibonacci sequence generation, right? So if I remove these words, which kind of hints that it is related to Fibonacci sequence, just imagine what hard time you will be having to just understand that this code is literally related to your Fibonacci sequence generation, right? And also, if you see the tokens that have been used, the syntactical tokens that have been used here, that is very much different, right? So we have move l, zor l. Now what does this zor l mean, what it is doing? Then what is this jbe, what does that do? We don't know that, right? So it was very difficult to understand. So then we moved on to a high level programming languages, as we do in basic, fortran, cobol. I know like we don't use these languages nowadays that much, but back then it was very popular. So what it used to do is there was more abstraction introduced. So with assembly languages we had one level of abstraction on top of the machine language code, and here there were more level of abstraction and human friendly statements which would internally be compiled or interpreted into the underlying machine code. But there was unstructured sequential lines of code. So in the second example that you see here, right? So I'm not sure whether you're familiar with the basic programming language, but this is a sample basic program. So here we see that we just have a few lines of code in front of us, and these are line numbers. So as you can see, these are line numbers. So sequentially, so the program will start executing the first statement here at line number 5. Then it will slowly progress till it reaches the end of the program, that is line 99. So this is a very sequential way of running the program. Of course, there is a construct to actually make you go back to previous statements, which is a go to construct that we see here. So as it mentions here, that go to line 5. So from here your control jumps to line number 5, and again it kind of does the same flow over and over again. So this behavior is somewhat like a loop that we see in modern programming languages, but here it is totally unstructured. So basic is a perfect example of an unstructured programming languages. But what are the advantages that we see here? The advantages is that the tokens that are used in the programming languages are very familiar to humans. So by reading this first line, let's say let s equals to 0, we immediately understand, okay, so they are assigning the value 0 to s, right? Then let's say we do this if n equals to 0, then 99. So if n is 0, right, then value 99 will be assigned to n, and then the programming execution will continue. Right. So basically by understanding or just by reading the statements, you will get at least a faint idea as to what the statement is going to achieve. But same cannot be said in assembly languages. Like I have absolutely no clue what this jbe.fib underscore done statement does, right? So it's very complex. So it was a jump. So from assembly language, we moved on to unstructured languages, which were more human friendly, and though it was still unstructured in nature. So here the concept of writing modular reusable blocks was practically non-existent, and the code base was very difficult to maintain Simple tasks would require hundreds of lines of code. As you can see, right, if it is not structured, right, you literally have to write this loop maybe hundreds of times wherever this loop is needed, because we don't have a concept of method or a function here. The code generally executed in sequential order, and we normally don't make the control jump to a specific code and then jump back. Each line of code, even if it is repeated, gets executed sequentially. We can change the flow of control using goto construct, but that is not the most elegant way of having good quality, maintainable, readable, understandable code base. Today we have huge code bases running our favorite apps on mobile, right? It's running on laptops, televisions, which would have been a nightmare to code on such unstructured programming languages. So let's say you have your favorite game on Android, right? Can we just think of writing the code for that particular game in a basic programming languages, right? It would have been an uphill task, a totally difficult one at that, right? So there was an urgent need evolving within the dev community to manage this complexity at some level, right? So the way forward for that was structured programming languages. So we moved on to structured programming languages. Now you might be asking that, okay, what is structured programming languages? Can you give me a few examples of such languages? So, well, the language that we are currently studying as a part of this tutorial series, that is Java, is one of the structured programming languages. And other examples would be like C, C++, C sharp, right? So structured programming languages, as you can see, is helps build modular code like Lego blocks, and using and reusing these modules we build our business functionality, right? So when the code within one module is executing, we can jump to another module and get those lines of code executed as well, and then again come back to our initial module and continue processing. So I'll give you one example. So this is a C code that you see here. This is written in the C language. So here what we see here is the program execution is starting from this main method. So your program starts executing here. So basically what this code is doing is it is adding two numbers. And here we have one module of code which actually takes two numbers, sums them up and returns the result. So this is a perfect example of a module. So you send it two integers, it will always give you back the result. So wherever you need this functionality within your main method, you don't have to replicate this logic. This logic is only written once now, right? Wherever you need this functionality, you just have to make a call like this. So I took two numbers, 10 and 20. Then I passed the numbers to this particular method that is called sum a comma b. Then the control actually goes to this particular method. It sums up both the numbers and returns the result. Now let's say after line 12, within the main method, I again have the need to calculate the sum of another two numbers. Again, I will use that same statement like this, right? And that will again go back to this particular modular code. It will execute it, get the result, and then display it. So this is how a structured programming language code is looking like. The key benefits of this approach was easier maintainability, easier to understand, of course, like you are able to understand that it is adding two numbers, right? And the logic which actually adds the number is also pretty clear, right? It is not cryptic as this assembly language, right? Because the structured programming language builds on top of unstructured programming languages. And as we have seen, unstructured programming languages are human friendly. They use human friendly language tokens, right? So basically these code are also easy to understand and comprehend, right? So debugging got easier, dev time got reduced, right? But with this approach, we also had few issues. Like we were not able to replicate real business problems at the entity level, and not much importance was provided to data and how it is protected from being modified. So everything, whatever you are processing, right, it boils down to data. So data is of utmost importance. It is the pinnacle of importance in your code, right? Not the logic. Logic actually works on some form of data, right? So the focus on object-oriented programming languages would be more on data than anything else, right? So there was a need emerging in the developer community for modeling our programs, our structured programs that we are writing in C, etc., right? With respect to objects or entities and their representative data and how to manipulate the same, which ultimately gave rise to object oriented languages like the one that we are learning right now, Java. So, in the interest of time, I will be covering Java and the Java buzzwords or its advantages and what is their significance in the next lecture. Uh, so, thanks for watching. See you in the next lecture. Thank you.